So I'll talk a little bit about what we are doing here down south in Brazil. We are talking about sustainable development goals from UN, and we are trying to see a method to get better planning actions inside the cities to achieve all these goals. And let me change. Uh, the contents, I'll talk a little bit about SENAI CIMATEC, just one slide, the place that I'm work as a research, a brief introduction, the method, two studies, some conclusions and perspectives of future work that we have. SENAI CIMATEC started in 2002. Today, it's a technical school, a higher education school, and a technology center in 4 buildings, all cooperating with more than 35,000 meters square. It's recognized as one of the main science and technology institutions in Brazil working with research, development, and innovation. If you want to know a little bit more about our institution, just follow the site senaiCimatec.com.br. There is a lot of information in English too. As an introduction, the Agenda for Sustainable Development adopted by all United Nations members provides a shared blueprint for peace, prosperity for people and the planet now and into the future. So we are talking about 17 goals, 169 targets. It's a lot of targets that need to be met. And how we can meet that targets? It's very difficult to plan each action inside each city to have the country meeting all these goals. Let me talk about two different goals that we have and we work at a little bit. The goal 3, ensure health, lives, and promote well-being for all ages. There is a lot of progress, but this goal needs acceleration. For instance, less than half of the global population is covered by essential health services. Indicators that can monitor in this goal is more than 70. And for instance, there is one interesting indicator for us here in Brazil, neglect tropical disease, cure rate. So dengue, it's arbovirus that occurs here in Brazil, and I will talk a little bit about that too. The second one, it's the 11th goal, make cities and humans more inclusive, safe, resilient, and sustainable. In 9 years ahead, provide access to safe, affordable, accessible, and sustainable transport system for all, with special attention to the needs of those vulnerable situations, like human, children, persons with disability, and older persons. This is other thing that we're gonna talk with this method. For instance, only half the world urban population has convenient access to the public transport. Then, with limited resources, we know with COVID-19, it's very difficult to get all the resources we need to meet the SDGs. I have two questions. It's possible to understand the path taken by the spread of dengue fever in a region, and cities can prioritize the right place that you receive actions to eliminate the vector of dengue transmission before the epidemic starts. And in the other side, it's possible to find areas in a city where rainfall impacts access to the public transportation. The method we are applying came from modern physics. It's the trended cross-correlation coefficient. It's called whole DCCA. The whole DCCA can be applied in different areas of knowledge. It's the ratio between the trended covariance function of the trended cross-correlation analysis and the variance function without trend of the trended fluctuation analysis in two different time series. It is calculated according to Z-band and created in 2011. This method can quantify the level of positive or negative cross-correlation between non-stationary time series and identify seasonal components. It's an index varying from -1 to 1, where 1 is equals to a perfect cross-correlation and -1 is a perfect anti-cross-correlation. Interesting point, it's not a simple cross-correlation, but it goes through fractals and complex systems. It's a robust method that can be used in interdisciplinary issues or questions. The first problem that I want to show the method in use, it's about the elderly and people with disability sustainable mobility. So the hypothesis, when there is a rainfall, we have elderly and PWD people going outside to the bus, not getting access to the transport system, to the bus system. Some points in Brazil about elderly. The quantity of elderly in Brazil, it's growing each year. So it's expected to be in 2060, we're gonna have 73 millions of elderly in Brazil. It's a lot of people. And PWD worldwide, just to know, 15% of the world's population experience some form of disability. And with COVID-19, persons with disabilities needs to get accessible transport may not be able to travel, even for their basic necessities or critical medical appointments. How can we determine the areas that need to get more attention from the government to get actions? We used the whole DCCA to quantify the impact of the rainfall and the number of PWD and other people who use the public bus transportation system and the first and last miles of São Paulo. São Paulo is a big capital in Brazil, from the state of São Paulo. And what we found is, as you can see on the green side, you have a negative cross-correlation value for the transportation of elderly and PWD people and rainfall. At the same time, you have an increase of the index with paying people. Everybody that is not elderly and PWD in Brazil pays for the fee to get the bus. And when it's raining, these people get more buses. This is the main point that you got here. It's the way we were able to measure how much the rain impacts on this accessible transportation. The next slide, we can see the area that requires actions from governments to provide an accessible transport system for all. So those are the points, those are the bus lines that we found the worst cross-correlation numbers. So if the government in São Paulo wants to create a better accessible transport for the people, he needs to take a look in this region in São Paulo. And this is one way to get a better transportation system for all. The second study is about the dengue in the world. In 2007, we have this map showing how the dengue is was reported officially between the regions. These dengue cases include clinically suspected and laboratory confirmed cases. As you see, there is a lot of problems worldwide. We took an example here in Bahia. Bahia is a state in Brazil, and we tried to find the way that the spread of dengue goes through the state. So we divided the state in economic regions. Starting point for this study is Salvador and metropolitan area, this point here, in the right side of the map. And the annual total precipitation in Bahia is less than 1,000 millimeters annually. It's a dry region. What we found here, we found that first of all, in 33 days, there is medium and strong cross-correlation between the dengue results just closer to the Salvador. And this spread goes through the map 91 days, more than 150 days, almost in a year, getting everything medium, as a medium cross correlation. What that means? That means if you have a epidemic dengue in Salvador, you're gonna have this epidemic dengue over all the state. And what you can get with these results, that you have 30 days to get the first actions to avoid the human to mosquito to human cycle of dengue. And this is the way we can combat dengue. And the region that we need to act on the first 30 days of the epidemic is this region showed in the map, close to Salvador, just 3 regions. This is the way we can combat dengue in Bahia without spending too much money with limited resources. We have 30 days and we have limited resources. We can do we can create actions inside the area, the orange area, to avoid a huge epidemic inside the state of Bahia. Some conclusions I got. HODE-CCA can show cross-correlation results between time series of complex systems, and it's a powerful index to create insights from fluctuation analysis to accelerate some of the SDGs realization. And pointing the SDGs needs more scientific research to accelerate its realization. We are seeing a lot of targets that countries are not meeting, and we have to spend our research time as scientists to get it done. It's important to the world. As a perspective and future work, we have 17 goals, 169 targets, and a lot of monitoring indicators. But we have a huge need to efficiently plan actions to achieve our SDGs. This is my suggestion for future researches in this field. I want to say thank you to the collaborators of this work, Marcelo Moretti, Aloysio Nascimento, Renelson Sampaio, Hugo Saba, Gislaine Azevedo, and Paulo Ferreira, our friend from Portugal. And thank you for all to listen. Thank you all for listening to me in these minutes.